Despite the scary crypto headlines, enterprise blockchain continues to evolve as a practical way to do business. When blockchain hit the scene in 2009 with the release of its first application, the Bitcoin cryptocurrency, it had a Wild West feel akin to the early days of PC hackers. Blockchain used a decentralized peer-to-peer architecture that let anyone participate, which made it seem too risky for business use. That started to change in 2016 when a burgeoning open-source community started developing complete enterprise platforms. Over the next several years, household brands like Bumblebee, IBM, Walmart, and Visa touted their blockchain deployments. AT&T, Starbucks, and Tesla began accepting cryptocurrency payments, and Bitcoin landed on some corporate balance sheets. IT heavyweights AWS, IBM, Oracle, and SAP got behind blockchain in a big way. Then the crypto winter of 2022 brought cryptocurrency prices crashing down. Some crypto exchanges went bankrupt and their CEOs were arrested. The bad news kept coming in 2023, with more arrests and the US government throwing the book at the Coinbase and Binance exchanges. Crypto winter turned into the crypto summer of hellfire. But businesses are moving ahead, albeit with more awareness that the risk and expense of blockchain must be managed carefully. They've also gotten wise to the blockchain will change the world hype and homed in on low-risk, quick payback applications. Still, blockchain's technical underpinnings and practical implications can be hard to grasp. When considering blockchain, you need to have a clear picture of what blockchain does and doesn't do. Understand the effects of the deployment options, especially network architectures, and know where to use blockchain to complement rather than replace existing systems. Here, we'll cover the basics of blockchain technology and what businesses need to know. For a deeper dive, explore our complete collection on all things blockchain by clicking the link above or in the description below. Blockchain is essentially a database technology with attributes that, when you take them alone, aren't unique to it, but collectively, they produce a technological breakthrough in how digital information is stored, verified, and exchanged. Most of blockchain's key attributes come from being a type of distributed ledger technology, or DLT. DLTs disseminate copies of a ledger to the nodes on a network, making each one responsible for recording new transactions and participating in a consensus mechanism to agree on updates to the ledger. Blockchain's unique data format is another differentiator. Traditional databases store data in rows, columns, and files, while blockchain stores data in blocks that are linked together and protected by cryptography. The data block and transaction verification mechanisms make it just about mathematically impossible to hack a blockchain and change the data or disrupt transactions. There's no central authority for malicious actors to target, and there's no one player who can privatize data, change the rules without agreement, or bring down the whole network because of a technical failure. That's how blockchain achieves what's known as immutability. The ledger is essentially permanent and tamper-proof, and can therefore be trusted as a faithful record. The different types of blockchain are categorized by how open or closed they are to participants. There are 4 major types of blockchain. Public or permissionless blockchain doesn't require permission to join and is transparent to all participants. It's also typically the slowest of the 4 types because opening the blockchain's consensus process to so many participants makes data verification more tedious but also less vulnerable. Private or permission blockchain runs on a closed network, often under the control of a single entity that decides what's valid, which can raise issues of trust. Most of the high-profile blockchain deployments are on private blockchains. Hybrid blockchain combines aspects of public and private blockchains. Users joining hybrid blockchain have privacy until they enter into a transaction. And consortium blockchain, which is a lot like private blockchain but is controlled by a group instead of a single entity. Evidence is emerging that consortium blockchains are too expensive and don't provide a clear ROI for participants, and some have gone out of business. The most important business application for blockchain could very well be smart contracts, a type of program that uses business logic to execute agreements and transactions between blockchain participants. Smart contracts could completely automate the exchange of money, delivery of services, granting of access to digital content, and enforcement of privacy protections. Blockchain's attributes can also play a prominent role in several other applications. Supply chain. Blockchain expands the number of suppliers and buyers and helps ensure the integrity of data passing through the supply chain, thereby getting closer to the elusive goals of supply chain visibility and transparency. Cryptocurrency. Bitcoin and other digital currencies have moved past the fad stage as high-profile companies like Tesla add them to their investment portfolios and accept them as payment for some products. Cybersecurity. Blockchain's strong encryption and other security safeguards make it another tool in the security toolbox. Internet of Things. Blockchain ensures the integrity of IoT sensor data moving up the supply chain from fields and factory floors for asset management, environmental compliance, and traceability. Storage. Blockchain's decentralized peer-to-peer architecture can piece together the unused disk space of blockchain participants, creating blockchain storage. Banking and finance. Despite the recent setbacks, cryptocurrency continues to gain credibility as an alternative payment mechanism in a global monetary system largely run by government central banks and payment providers like MasterCard and Visa. Healthcare. Blockchain security, privacy, data integrity, and anonymity are enabling new uses of genomic data and medical records of individuals to support pharmaceutical research. And government. It may soon become legal to transmit personal identification, vote, acquire a passport, and prepare legal documents and regulatory filings such as mortgage deeds and financial reports online. Investing in enterprise blockchain may eventually be essential just to keep up with the Joneses. Corporations paid serious mind to breakthroughs like the PC revolution of the 1970s and 80s and the World Wide Web's boom in the mid-90s. Many experts believe blockchain will command the same attention for competitive reasons. But herd mentality isn't the only thing driving blockchain. The technology can reduce IT costs, expand B2B and B2C networks, enable new products, and open new revenue streams. Specifically, enterprise blockchain is best for processes that involve multiple parties, and each party needs access to the same data, but has slightly different or out-of-date information that has to be reconciled. Blockchain removes middlemen and mostly automates processes that take time and effort. Blockchain can help businesses expand their customer bases, reach them more efficiently, and broaden the universe of suppliers and partners. Blockchain's level of trust makes it possible to do business with unknown parties, potentially expanding markets and the demand for products and services. Blockchain's data accuracy, impermeability, and privacy can reduce fraud, eliminate data leaks, and help attract more customers and partners. And blockchain's transparency, visibility, and traceability benefit supply chain management, especially to shore up trust and information about product provenance as the goods move along the supply chain to consumers. Despite all the positives, there are big considerations to keep in mind. Blockchain represents a fundamental architectural change for data centers, which typically use centralized databases and concentrate their computing power in fewer locations than blockchain. Meeting the anticipated demand for blockchain will require major infrastructure upgrades. In addition, adopting blockchain for serious enterprise use carries above-average risk of choosing the wrong platform, incurring cost overruns and delays, and failing to achieve positive ROI. And blockchain's a target. Many weaknesses come from malicious actors figuring out ways to exploit the rules of the blockchain. Smart contract security is especially problematic. Smart contracts are attractive targets since they can move large amounts of valuable data and financial resources. Blockchain also requires large numbers of participants for most of its benefits to be realized, especially public blockchain. And blockchain skills are in short supply. But that's rapidly changing as training and certification rises along with the demand and compensation for blockchain developers and engineers. And it's not very eco-friendly. There's a growing awareness that blockchain's compute-intensive processes, especially for proof-of-work consensus and Bitcoin mining, are among the biggest users of natural resources in all of IT. Blockchain is one of a handful of cloud-based technologies considered essential in digital transformation and the intelligent enterprise, along with AI, advanced analytics, and IoT. Among the more promising building blocks for blockchain is its merging with AI. Also, blockchain is now understood to be foundational to the next generation of the Internet, Web 3.0. Still, a lot has to happen before blockchain can replace today's methods of sharing data and conducting transactions over digital networks. Now that blockchain development tools and frameworks are proving their viability for enterprise applications, widespread acceptance of blockchain is no longer a distant mirage on the horizon.